Hi, and welcome to our lesson on telescopes today. I'm excited to bring you on a journey where we will discover the history of telescopes and how the early telescopes was invented and worked. We will then look at a few of the modern day telescopes and the amazing discoveries they've made. In this journey, we will discover the social impact of telescopes and how they've changed the world around us. And finally, we will take a peek into the future to discover what is coming our way through the telescope lens. Are you ready? Let's begin. The history of telescopes. Humans have been staring into the skies ever since evolution occurred and wondered about the amazing shining objects in the sky. Historical records show early humans drawing on cave walls their perceptions of star arrangements in the shapes of animals. It wasn't until the 2nd century that a Greek astronomer Claudius Ptolemy was able to tell a scientific story about the sky. He created a model that positioned the Earth at the center of the universe. His model was so convincing that it became the textbook of knowledge about the skies for 1,500 years. His model was well loved by the religious factions that sought to put the Earth and humans of God at the center of everything. And to do this became the truth of the time. It wasn't until 1608 that this theory was debunked and the world finally started understanding the skies and the marvels out there. In 1608, a Dutch spectacle maker invented a tool that positioned to see how far things were and how clearly they could get. We'll talk more about this later, how this works later on. Lippershey's telescope allowed objects to be magnified up to 3 times, an amazing feat for his time. The Dutch military used his tool to spot their enemies far away on ships, and it became a spy glass for the military. Other scientists soon heard about his invention, and the race to create the best telescope began. Galilei Galileo, an Italian scientist, then invented his own improved version of the telescope by reconstructing Lippershey's telescope. His telescope magnified objects first to 8 times their size and eventually up to 30 times. He was also the first to point his telescope in the sky to look at the moons and the planets, and of course the stars. The scientists of this era finally proved that the Earth is not at the center of the universe and that the Earth actually traveled around the Sun. This did not sit well with the church, and Galileo was imprisoned in his home for the rest of his days. The invention of the telescope also had far-fetching effects on society and the world, and we will discuss this later. Let's carry on with our journey first. Another great scientist of the time, Johannes Kepler, made a modification on Galileo's telescope by using a different type of lens called the convex lens as the eyepiece, which allowed images of the planets, moons, and stars to be much clearer. However, both of these telescopes were limited by how much they could magnify before the image became too blue. This phenomena is known as chromatic aberration and is caused by the fact that the colors of light travel at different speeds and hence are unable to focus when they pass through the lens after a certain distance. So the problem was the big lens at the end of the telescope. In 1666, Isaac Newton then invented the reflector telescope to overcome this problem. The reflector telescope collected all the light from the image through a paraboloidal or a curved mirror and then reflected it through a secondary mirror onto the eyepiece lens. This removed the need for the objective lens, the lens at the end of the telescope, and with it, the problem of chromatic aberration. Finally, another important scientist in the world of telescopes, Laurent Cassegrain, modified Newton's design by changing the design of the reflector telescope so that the image formed by the reflection would pass back through a hole cut out in the mirror and straight to the eye. This reduced the length of the tube required to put together a telescope. The practicality of this design allowed modern satellite telescopes to be invented. Up until 1835, the mirrors used in the reflector telescope were actually polished, specular metals, and hence were limited by the imperfections on the metal that distorted the image. The invention of the glass mirror in 1835 allowed images to be magnified by 150 to 200 times. The final challenge to telescopes was the effect of the atmospheric gases that distort the image as it passes through this layer of the atmosphere. The atmosphere is responsible for the twinkling of the stars, which is as beautiful as it seems, is actually a challenge to scientists trying to see much further into space. As a result, telescopes have been launched into the sky to see over the atmosphere of the Earth. One of these famous telescopes is the Hubble telescope, a reflector telescope launched in 1990 by NASA with a diameter of 2.4 meters. This telescope uses computers to collect the data and transmit it to Earth. With Hubble, we were able to make discoveries of the age of the universe, how the universe was formed, as well as peek into other galaxies. In 2021, a much more advanced space telescope called the James Webb Space Telescope with a whopping 6.5 meter diameter mirror and the capability of using deep infrared technology was launched into space. This telescope has provided a clearer picture of how the galaxies interact and form. It also allowed us to peek into other universes through images that were otherwise very dim by using the deep infrared technology. We shall look at what the future of telescopes hold at the end of this video. So, hold on tight. Predicted to launch in 2026 is the Nancy Grace Roman Space Telescope. This telescope will have a field view larger than at least 100 times of the Hubble Space Telescope that will allow us to look deeper into further galaxies as humans search for extraterrestrial beings as well as inhabitable planets and answer the ever-pressing question, are we alone in the universe? Now, come on, let's see how telescopes work. A telescope is a tool that helps magnify far-away objects and make them look clear and closer to us. To understand how the telescope works, we need to first understand why we can't see as far as we would like to. The image formed on our eyes depends on two factors: the amount of light that bounces off the object onto our eyes and the amount of space that image takes up on the screen of our eye. Hence, the more successfully we can overcome these two challenges, the clearer and further we can see. So, let's look at the most basic telescope similar to what Lippershey or Galileo would have invented. The refractor telescope. In this telescope, we have a larger lens at the front end of the telescope called the objective lens. The objective lens is responsible for collecting as much light as possible and transmitting it through the tube. This lens then bends or refracts the light towards a central point inside the tube called the focus. We know that light travels in straight lines, so this image will pass through the focus and onto the eye. As stated just now, the purpose of the objective lens is to collect much more light than possible otherwise and bring it from the image to your eyes. Now, the next problem would be that image, although much brighter now, will be very small as it will take up a small space on the screen of our eye. To overcome this, we have another lens at the eyes called the eyepiece to magnify the image that is formed on our screen. By moving these two lenses to an optimum point that matches the focus, we can see objects which are very far, clearly, and much larger than the naked eye. Now, let's look at the refractor telescope. Do you remember what the other type of telescope is called? That's right, the refractor telescope. As we discussed earlier, this telescope works on a similar principle as the refractive telescope. However, instead of collecting as much light as possible through the objective lens, the refractor telescope uses a curved mirror, also known as a concave paraboloidal mirror. The collected light from the mirror is then reflected through a secondary mirror, which reflects that image onto the eyepiece lens. This principle is still used in modern telescopes, such as the Hubble Space Telescope and the James Webb Telescope. Now let's look at the social and the societal impact of telescopes and the world around us. Just around the time that telescopes were being invented, the scientific revolution was beginning to change the world. People were tired of being ruled by aristocrats who used the church to create rules and laws about everything. Questioning the laws was not accepted and meant imprisonment or even death. However, the people now wanted evidence, a concept we call empiricism in science for all the theories and laws they were provided. One such major fact was that the Church endorsed and enforced that the Earth was at the center of the universe and the Sun and all the other planets revolved around the Earth. With the invention of the telescope and the evidence it provided, this led to a paradigm shift where science provided evidence and the Church was forced to step away from many scientific and political matters. This led to more scientific discoveries in the fields of chemistry, biology, physics, and other fields of science as well, and changed the future of the world. Today, with the help of telescopes, we have been able to discover the beginning of the universe and are steps closer to finding out if we are alone in the world, or if there are other intelligent species like us in other galaxies far away. Now, let's look at the future of telescopes and the world around us. The latest telescope to launch, the James Webb Space Telescope, has the ability to see through the dust and gas of other galaxies to the point where stars and planets form. With its deep infrared vision, it can view objects that are very, very dim from far away. Building on this technology, the next telescope to launch in the coming future is the Nancy Grace Roman Space Telescope, which will be able to cover an area 100 times larger than the Hubble Space Telescope. This space telescope will be able to look for galaxies where there are planetary arrangements like ours, and perhaps harbor life and other intelligent beings like us. It will also have the capability of studying dark energy and dark matter that makes up 95% of the universe, for which we have very little knowledge about, and which does not give off any light. Hence, we hope this video has sparked your interest in astronomy and the science behind it. You will learn about these concepts in depth in your Year 11 and 12 physics course. Thank you for watching this far, and remember, the universe is yours to be discovered. Till then, see you around.